halide. And today we'll start the Hoffmann's bromamide reaction, which is most important reaction, naming reaction. This is also used, this actually, I would say it is applicable for both. And for your practical portion, this is most important topic. Like they may ask, your examiner may ask, name the test which can confirm 1 degree aliphatic as well as aromatic amine. So this is the reaction. Okay, Hoffmann bromamide reaction. And here the product which we get over here, amine, right? No? Primary aromatic and aliphatic amine. So name, they may ask you the reactant, reagent, in which state they work. All such questions may have, right? Degradation, what is Hoffmann's bromide reaction, why it is called as a degradation reaction. Okay. So since we have obtained the product after loss of carbon atom, so we can call it as a Hoffmann bromamide degradation reaction. All such questions I'll discuss tomorrow. Okay.
Yes.
So your teacher might have given you Viva voice questions also. Did she give? List
Yes,
with you?
ma'am. She gave.
It is there. Correct now. So it's all functional group. All those tests are there, but it's very simple. No worry. Okay, let's begin here. So you can check there. Hoffmann's bromide reaction is given. Is it given?
Yes, ma'am.
So let's begin this reaction. It's applicable. This reaction is applicable for 1 degree aliphatic and aromatic amine. So I'll help you how to identify the reactant over here. Okay, everything is hidden in this name itself. Let me highlight that part. It's a bromamide. Okay, this part helps a lot to identify many things. Look at over here, bromine and the amide. These two are the things actually we have as the key point over here. You know amide ka, what is the amide ka symbol? It is R, C double bond O and NH2. This is amide ka symbol. Okay, and we have bromine as well over here. Okay, so this is reagent. What do you call this as? Reagent. And this is your reactant. Clear? What is this? Reactant. Did you understand?
Yes, ma'am.
Correct. So Hoffmann bromamides reaction, it helps us to get 1 degree aliphatic as well as 1 degree aromatic amines. Okay, this is applicable for 1 degree aliphatic as well as aromatic amine. So aromatic may we have only one compound. Like example, I would say aniline to be studied. You don't have much in this. Okay. This is clear? Information is enough?
Yes, ma'am.
Good. So Hoffmann bromamide say never like we have, and why? Yeah. Next question is why it is called the degradation reaction. So let's see the reaction, then we'll talk on degradation topic. So we are going to take the reactant our amide, our C double bond O NH2. This is amide compound. Will be treated with the bromine reagent, and in alkali, in aqueous form of alkali solution, will be taken this. Okay, this reaction upon heating, we heat this compound, and look at over here, we have this carbonyl group, right? This is getting lost. Correct. This compound basically getting lost. So that's why we say, since we are losing carbon atom less than the amide, what one carbon atom get less than in amide, so we can call this compound as the degradation. Degradation means getting something less, right? Going to loss, right? Correct.
Yes, ma'am.
So we can say this very simple it is. We are just removing this part and R and H2 gets attached. Are you clear? It's looking simple.
Yes, ma'am.
So we get as the primary amine, RNH2. Right? And then over here we get the sodium bromide, bromine and sodium. This reacts. So we know the formula. NaBr is the product, means formula. Sodium is monovalent, Br is monovalent. Correct. This compound, the CO which has come out, right, carbon double bond oxygen, this gets with this compound. And again, because here the sodium is taken in a higher form, the concentration will be more. So this reacts with again sodium, and this comes out with this oxygen in the form of carbon dioxide. Carbonyl and oxygen comes out in the form of carbon dioxide. So what do you get as the product? Sodium carbonate as well. The byproducts are more in this. Okay, sodium ka two salts you get. You need to remember two salts of the sodium we get in this reaction. One is the sodium bromide, because bromine is here and sodium is here. And since there is a loss of carbonyl group, definitely that goes out in the form of carbon dioxide, right? Along with the oxygen, alkali is also present over here. So we get as the product sodium carbonate. Now what is left over here? We can have over here the hydrogen and oxygen left, that forms as the water. Did you understand?
Yes, ma'am.
So you need to just prepare that. This is very simple. What is the reactant and the reagent, and how we get the product as the 1 degree amine. Everything is easy. Only the thing we have to prepare one thing. We get the two salts. One is the sodium bromide, another is sodium carbonate, NaBr, and other is Na2CO3, sodium carbonate. Okay. So now we need to think, if we have to prepare methenamine, then we have to take acetamide. If we have to prepare aniline, then we have to take benzamide, such compounds. We'll do the reaction. Okay, no worry. Let's balance this reaction. Sodium, we have two over here, total three right hand side, and left hand side one. So we can make it odd even number, like even number. How will you make? By increasing the sodium, because Br we have two over here. So based on that, based on this, we can make 2 moles. Now you can see this is come an even number. Seeing the numbers, we can substitute 4 over here. Are you understanding how we go with the number of moles? Now the number comes to what? The hydrogen. Okay, 2 hydrogens over here, 2 hydrogens over here, 4 hydrogens over here. It means there are 6 hydrogen left hand side, and right hand side we have 4. So to make it balance, we'll add 2 more. Is this clear now? And oxygen at last, you can see oxygen is balanced. 1, right? We have 4 over here, right? And you can count over here 3, right? And the 2. So total 5. So it means the oxygen is also balanced. So elements are balanced now. Now let's see the examples, how we can produce aliphatic and aromatic amine. One example will each we'll see. Okay. So CH3, C double bond O, and NH2. It can be written CONH2 also. So I am showing the carbonyl bond always, so it will be clear. Plus Br2 plus sodium hydroxide in aqueous form. What do you get as the product upon heating? Tell me. This is the amines ka symbol, RNH2. Okay, so we are, what did I do? What did I do? I just remove this. So what will be the product, Hridaya? Hridaya, can you hear me? Yes, CH3 NH2. What do you call this as? Methenamine. Correct, right? Yesterday we have learned. Did you see the PDF?
Yes, ma'am.
Check today also. Today also you can, if you get time, please go through with the notes once. Sodium carbonate over here we get as the product, and plus water. Okay. Now balancing part goes same manner. Okay. That's all. Done. Let's see one. This is an example of 1 degree aliphatic amine. Wanted to do one more aliphatic amine example? Let's see. Let's increase the number of carbon. That's all. This you do by yourself, Hridaya. Try this. You can do it. Okay?
Yes, ma'am.
Do this.
CH3, CH2,
Very
NH2.
nice. CH3, CH2, NH2. Give the name to this compound. How many carbon atoms you have? 2. This is 1 degree amine. So tell the name.
Ethanamine.
Very good. Ethanamine. Super. And plus what you get as the product? Byproduct sodium K salt, NaBr, and sodium carbonate, Na2CO3. You know how to frame the formula, right? By their ions, suppose if I'm asking what is the formula of calcium carbonate, because this will help you to write the salt analysis may at last the result. So calcium ion as the basic radical and carbonate ion as the acid radical. So we get as the product, what product it is formed as?
CA3.
Crisscross, right? We will exchange these ions as the subscript. Calcium takes this 2 and carbonate also takes this 2. So both are divisible by 2. So get cancelled. What do you get as the formula? CaCO3. Suppose if I have to get potassium carbonate, then potassium is monovalent plus charge. Carbonate ion is 2 minus. What will be the formula, Hridaya? By exchange, these ions get exchanged and comes as a subscript. So this gets 2 over here. The ions won't be written, numerals written, right? And the CO3 ka whole N1 we get. Correct. The formula comes as K2CO3. We haven't done the division over here because these are not divisible. 2 hai, 1 hai. So it is not divisible, right? Clear?
Yes, ma'am.
Okay. MgCl. Mg2 plus and Cl1 minus. What will be the formula? Mg takes the 1 for of Cl and Cl takes the Mg ka 2. So the formula comes as MgCl2. Did you understand?
Yes, ma'am.
Okay. Sodium sulfate. Try by yourself. Do you know the symbol, Hridaya? Sodium is Na plus and sulfate is SO4 2 minus. So what is the formula?
Na2SO4.
Very nice. Na2SO4. See, you have learned very quickly. Good. Well done. So this is how we can frame the formula. In case if you don't know formula, you can little work out in the rough note and check whether you are writing the correct formula or not. Once you get the correct formula, then you can go for balancing. No worry. Okay, you will get the correct answer and you will score a full marks. Okay. So not to by heart anytime. Don't by heart or don't prepare any equation along with the number of moles. Okay. Try to prepare the skeleton reaction. Skeleton means which is not balanced. You know the concept, skeleton reaction, and then try to balance. Got it?
Yes.
Done. We'll do 1 degree aromatic amine. How to prepare this compound? So let's take benzenamide. So C6H5 I'm taking instead of drawing a ring, and CO I am putting carbon double bond oxygen ki jagah. And now here we are having bromine and alkali aqueous. Same moles will be required. Later we'll see after balancing the equation. So what you get over here, again, we are going to skip this part and benzene gets the NH2. So what is the product for there? C6H5 NH2, which is called aniline. Did you understand?
Yes, ma'am.
If I write, suppose, in a structure form, how will I write? I'll draw the benzene, then C65. This is C6H5. C6H5, why do you call? One hydrogen is not present over here. Benzene is C6. Every corner, if you can show the hydrogen, then you can say it is C6H6. But if I just miss one hydrogen from here, so what do you call this as the formula? C6H5. The same thing I have written over here. So that hydrogen place, now you can see one hydrogen place is vacant. This place is occupied by NH2 group. So we call this as now aniline. You have learned what is aniline? So all the hydrogens which we have, these are hidden. These all hidden. It's understood that these other places where you do not have any group, that place is hydrogen present. Okay, Hridaya?
Yes, ma'am.
Good. Now, what will be the byproducts, Hridaya? Help me. 2 sodium salts, name you tell. Sodium bromide and sodium carbonate. The formula NaBr and Na2CO3.
Yes,
Correct?
ma'am.
And water. Okay. So here we will increase the number of moles and total 4 moles over here. You can see the number of moles not changing. Everywhere it's common. So did you learn this Hoffmann Bromamide reaction?
Yes, ma'am.
Good. It's very important. And why do we call it as a degradation reaction? This is also degradation reaction. Let me mention. This is also called as degradation. So why do we call it as a degradation reaction? Did you learn the reason? Hridaya?
Yes, ma'am.
The product which is obtained, right? Product obtained when? Tell me. After one carbon atom is lost, or you can say the product obtained has one carbon. We can make it little simple. Product obtained has one carbon atom less, right, than amide. You can see complete C and O is going out. So this is the reason. You can write in your sentence, but always remember you are writing the reason that loss. Correct?
Yes,
So
ma'am.
this is degradation reason, and answer is here. Chalo. We are done with the Hoffmann's degradation reaction, means bromamide reaction. I help you to how to know in case if you forget the reactant in the reagent, the name itself will help you to find out. Reactant is amide. Amide ka symbol is RCONH2. It's hidden in the name itself, and bromine is the reagent. The reaction takes place in the presence of alkali aqueous solution, and this reaction helps in the preparation of 1 degree 2 degree, sorry, 1 degree and 1 degree aliphatic and aromatic amines, right? Let's now start with the physical properties of the aniline. So if I'm talking up, sorry, amines, if I'm talking about the aliphatic amines, so aliphatic amine solubility and the boiling points, if I check, so that's all depends on their hydrogen, intermolecular hydrogen bonding. And here it is very, very important how to explain. Look at over here, the nitrogen connects with the 3 hydrogen atom, okay? And we have suppose one hydrogen replaced and one methyl comes over here. So we say this compound is, what do you call this as? Primary amine. So we say this is one holding one alkyl group. Here the alkyl group will be creating more basic nature over the nitrogen. We'll learn this property also. It's very, very important. So if you see the intermolecular hydrogen bonding, because our boiling point concept you are seeing from the beginning, this concept depends on interaction between the constituents. Mean we can say molecular hydrogen bonding or intramolecular hydrogen bonding. Any kind of hydrogen bonding must be present between the constituents. So we can say it depends on interactions of constituents. Right, Hridaya? So we are going to talk on that topic. So here let's talk, if I'm taking primary aromatic amine, primary and secondary would be able to make hydrogen bonding by itself, like many possibilities we are having. Okay, so if we try to draw, let the R to be kept down, okay, hydrogen to be next to the other molecule. So we can have an nitrogen, because nitrogen is the electronegative atom. So hydrogen bonding always will be formed between electronegative atom and the hydrogen atom of the other molecule. So we are going to keep hydrogen here. Okay, Hridaya, are you able to understand?
Yes.
The circle is in given space for the methyl. This is not in participation of the intermolecular hydrogen. And whenever you draw, Hridaya, what you can set the diagram. How do you set that? It's like you are going to make. You have other way also, making very simple form. Just a minute. We can go for. Now it is clear. Both are looking in a similar position, right, Hridaya?
Yes, ma'am.
So next molecule also you can say intermolecular goes. So you can see here in this case 1 degree amine may are able to form intermolecular hydrogen bonding, right? Intermolecular hydrogen bonding is possible. This is with the 1 degree amine, right? 2 degree also have possibility forming hydrogen bonding. Look at over here. We'll keep hydrogen front, right? And 2 methyl away from this balance, we can say sharing part, so that, and now we will keep nitrogen over here, again hydrogen next to this, and methyl over here. I think this would be easy for you, right?
Yes, ma'am.
So just remember, Hridaya, we need nitrogen and hydrogen in front of each other so they can approach and form intermolecular further continuity. Did you understand?
Yes.
Hmm. So these are the intermolecular hydrogen bonding we can see possible between 1 degree, 2 degree aliphatic amines. They are forming intermolecular hydrogen bonding as well. But this facility is not available for 3 degree because there is no hydrogen. Correct, right?
Yes,
Look at
ma'am.
over here, the 3 degree. In 3 degree amine, you have all sides methyl, means alkyl, can be methyl, can be ethyl, anything, right? So do not have hydrogen. So 3 degree amine does not contain, right? The boiling point of 3 degree will be very less than primary and secondary. What will you will write the reason? Now, I hope you are now prepared with the reason. You can make yourself. Now, what would be the reason? Tell me. Yeah, Hridaya, open up. No worry. You whatever. If you say a wrong answer, I am here to correct you. But you tell the answer. Try to do.
Mhm. Because
There's no intermolecular hydrogen bonding. Correct?
yes, ma'am.
Yes. Right. Now we if we talk so in boiling point, if I discuss with the boiling point behavior, how will it vary? The molecular mass it plays very important role, but here we say the interaction between the constituents also playing very important role. Primary amine is greater than secondary amine, right? Which is greater than tertiary. Tertiary has least. So the reason behind it, intermolecular interaction. 1 degree, 2 degree, and least one is the 3 degree. We have seen the structure. Now, even the question can be asked why this reason you please remember, Hridaya, it's very, very important. No intermolecular hydrogen bonding in 3 degree amines. ठीक है? So please remember this reason. So you can help, you can explain. Now even can be asked like why primary is having higher than secondary, because secondary also shows, right, intermolecular hydrogen bonding. So we can see here the hydrogen bonding structure to be drawn and explained. When we are looking for the intermolecular hydrogen bonding, Hridaya, here is the one more possibility: other molecule of nitrogen can come, correct, from this side approach can happen and can form intermolecular hydrogen bonding. Did you understand? So from two sides we can have like intermolecular hydrogen bonding formation. It's like more, right? Can you understand?
Yes, ma'am.
See, hydrogen is available, right? One hydrogen is available here. So these hydrogen also may go for the intermolecular hydrogen bonding. So in primary, we can say more possibility or maximum possibility we can see in the intermolecular hydrogen bonding. Whereas in secondary, we have less, right? So that's the reason 1 degree amine will be stronger than 2 degree amine, right? And when it is stronger, obviously bond cleavage will not take place so easy, right? Very easy. So we can say that primary is highly showing high boiling point than the secondary amine. Now our all discussion is based on the intermolecular hydrogen bonding only. Now we can see even with the water how it is getting interacted, how the miscibility will be depends. So if we are talking about the aliphatic amines lower molecular mass, like the first 1 degree 1 degree amine mein methane amine, ethane amine, so they form hydrogen bonding with water and they are soluble. Got it? But excuse me, but if they increase the molar mass of amine, so what happens? Suppose the 1 degree amine, right? So suppose we are going for higher number of carbon, CH3, CH2, 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 NH2. Okay, some just random number I have chosen and a bulky group I have made of the alkyl. So this alkyl group, due to higher molecular mass, right? Higher molar mass, it will become hydrophobic in nature. This will be hydrophobic. Hydrophobic ka matlab ki it has a phobia with water, right? Means hating water, does not like water. Did you understand?
Yes, ma'am.
Correct. So this part we call as a hydrophobic. So they become immiscible. Immiscible ka matlab ki insoluble, right? So these compounds not soluble in water. Though they are primary aromatic amine capable to make intermolecular hydrogen bonding, but their large alkyl group, which is hydrophobic in nature, does not allow them to prepare intermolecular hydrogen bonding with the water because they show hydrophobic behavior. They go away from that group. Correct? Means water molecule. Did you understand solubility? But lower, tell me the lower one. Lower member of amines are soluble in water due to formation of intermolecular hydrogen bonding. I hope I'm clear to you, Hridaya.
Yes, ma'am.
With water. This has to be written because with water, if they are capable for making bonding, then only they will be miscible. So this is about the solubility I have discussed with you. And this is the second physical property, most important. Very, very important question. We have like so many questions here will be asked, like if you are given the butane one amine and butane, like it can be compared with alcohol also. So which is more soluble in water, and why they can ask the question. So you can say that alcohols are more soluble than water, compared to amine. Their solubility is maximum, because alcohols are polar also, and water is a polar. So solubility follows one law, like dissolves. I think I have discussed with you, like dissolves like. It follows this rule. So it means polar compound will be soluble in polar solvent, and non-polar compound will be soluble in non-polar solvent. So like dissolves like. This is the rule followed, I can say, for solubility, right? So what do you mean by this line? It means polar compound soluble in polar solvent, and non-polar compound soluble in non-polar solvent. So like dissolves like. Did you understand the meaning of like dissolves like, Hridaya?
Yes, ma'am.
So polarity means there should be two poles. So HCl, the example, first one ka example I am writing over here. Okay, the HCl is a polar compound. So it is easy to dissolve in water, because water is a polar solvent, universal polar solvent. Clear?
Yes,
And
ma'am.
let me take one example for the second one, non-polar. Non-polar may, if I take, suppose for example, an example, uh, aniline. Aniline is aromatic amine, right? So will it be soluble in water or not? That is question, isn't it? So let me take some other compound, for example, toluene, benzene, or alcohol, anything, right? So alcohol, will it be soluble in water or not? This is question. Because here we have learned that this is being polar in nature. Alcohol is polar, so we cannot take alcohol nature, correct, alcohol as the non-polar compound. Then what we can say, other compound like butane, hexane, like that example can be taken. Hexane, hexane means alkane organic compound, and this can be soluble in the benzene or the toluene, such compounds, correct. So what we can say, non-polar solvent will be compound will be soluble in the non-polar solvent. Clear? Solubility concept is clear. So sometimes they may give you examples and ask you what happens, or the reason why this has the more. Suppose this has given one butanol and butanamine, which is more soluble in water. So we say this compound, why it is more soluble. Alcohol are polar compound, right? So polar compounds will be soluble in polar solvent, and water is polar solvent, correct? So got the reason? So butanol will be highly soluble in water. Did you understand this all nature?
Yes, ma'am.
Good. Now let's do the next basic characteristics, how we can explain. So Hardya, here we have question framed for the amines, as well as for, like, we can have ammonia say comparison with the amine. Ammonia has less or more basic character than amine. Such question may be asked. So we will learn like basic characteristics in detail. We are going to learn. Let me tell you the EWG, EDG group. Are you prepared with that? Any confusion in EDG and EWG group?
No,
Just
ma'am.
tell the full form of this molecule, means this group name.
Uh, Electron donating group.
Electron donating group. Very good. And this one, EWG, is called as
Electron withdrawing group.
withdrawing group. Very good. So when we are talking about the basic characteristic, okay, So these group plays very important role. Electron donating group, like example, I would say methyl, ethyl, such examples. Na, they what do? They increase electron density over the nitrogen. First of all, okay, methyl hai, ethyl hai, all these examples are electron donating group ka. Okay, electron, yeah, donating. Electron withdrawing group, like nitro group we have, phenyl group we have, chloro group we have, cyanide group we have. These groups, they withdraw electrons, correct, and they decrease density over the attached element, correct. Whereas methyl and ethyl donate electron and increases density over it. So basically, if we remember Bronsted Lowry concept, so that will help us to know the basic nature or basic characteristic, okay, about amines. So here amine, look at over here, I will write the general structure. This is amine ka structure. Correct. So we say, since it contains a lone pair of electron, right? This is the lone pair of electron. It is like electron is always available on nitrogen, and amine is basic, correct? As per the Lewis concept. Okay. Bronsted-Lowry said, if the molecule is ready to take proton, right? If a molecule is ready to accept a proton acceptor is a base. Proton acceptor is a base. Did you understand? Which, according to which law we are going? Bronsted-Lowry, as per Bronsted-Lowry concept. So when you are talking about this compound, we will see here amine में nitrogen is always holding a pair of electron, and it is available for proton in the sense H plus ion, which has lack of electron, and it requires these two electrons. So when they approach, they can make a coordinate bond with them, and they can frame a molecule, right? That is ammonia, means ammonium salt related compound, isn't it? You have seen the reaction. So proton acceptor. Now, if I just add two groups in it, let's see how the basic characteristic will be influenced by adding these two groups. ETG group. These are electron donating group. Correct. What is their function? Their role. Their role is to increase the density over the attached substituent, or we can say the element. So where are they attached? They are attached to nitrogen. So already nitrogen has one pair available, but due to attached of the EDG group, means I would say electron donating group, electron density is going to be high, right? So I would write a keyword, increases electron density. Do you understand? The electron density means more electrons available, correct? Now you just think, Hridaya, if hydrogen ion gets more electron, so that molecule will be going faster towards to the right proton side, correct? Or proton, if sees there are more electrons, will attack more easily, isn't it? That means, as per the Bronsted, we can say, now since electron density has been increased, so this molecule, right, this atom, nitrogen atom, is now more available for sharing with the proton, correct? So we can say this increases the basicist character, right? Increasing electron density, and after increasing electron density, it increases basicity as well. Did you learn? So these lines in remember. EWG group decreases electron density. So how do they decrease electron density? See, withdrawing nature. So for example, if you have attached a compound nitro over here, what do? They take this electron pair from nitrogen and they start using for itself. Okay. So what they are making, less availability, right? They do not let the molecule to use this alone pair for hydrogen. So they make the molecule less basic in characteristic. Did you understand? Did you understand?
Yes, ma'am.
So they decreases electron density, and obviously then we can conclude that decreases basicity. So what we can say, a line more EDG group, right? Higher will be basicity, right? Clear?
Yes, ma'am.
Let's do. We can now compare. So two questions are there. The one is ammonia or methenamine. Methenamine versus ammonia. Okay, so they may ask you which is highly basic in nature. Okay, this question you may get. And sure, one question will be there. Either you will have the aniline ammonia versus or methenamine. Methenamine is 1 degree aliphatic amine example. Is this clear?
Yes, ma'am.
So you will have comparison with both 1 degree aliphatic amine as well as 1 degree aromatic amine. Clear? So let's draw the diagram and then we can discuss. Now look at over here, we have methenamine structure and I'm going to keep this pair in front of hydrogen ion. Hydrogen ion is called proton because there is only plus charge present inside the nucleus. Electron is lost by this, that is why it is carrying plus charge, right? So we can call it as a proton also, resemble to proton structure. Okay, so there it is clear.
Yes, ma'am.
Now, this is lack with the electron and this is extra with the electron. So it attracts hydrogen towards itself. Correct? And when it attracts, and this is the reversible reaction. Okay, one thing. When it attracts, what bond will be generated between them? Coordinate bond. Correct? So coordinate bond is where one atom gives electron and other atom accept electron. So nitrogen is donor, hydrogen is acceptor. Obviously, over here now we can see another way, proton acceptor concept way if you are talking. So nitrogen become the proton acceptor. So we can call it as a base as per the Bronsted concept. It is clear now?
Yes, ma'am.
Okay. Since this has entered, right? This you can keep the positive ion over nitrogen also, no worry. But you remember it is a salt, right? Next, let's see for ammonia. This is methenamine. Let's see ammonia. Ammonia mein we have all the three sides hydrogen. We do not have EDG group attached, right? So quite obvious, electron density will not that high. That high means as a methenamine has. You got your reason now? Instead of the C methyl, what does it have? It has hydrogen this side, and this compound has methyl, right? Methyl is EDG group. And what is the function of EDG group? Increases electron density over the nitrogen and makes more available for the hydrogen. And this is how a hydrogen accepted by the proton nitrogen. And since it is a good acceptor, proton acceptor, it will be a stronger base than ammonia. Correct? Coordination bond will be generated, but which is highly? That is the question. So which is high? Tell me. Hridaya? Methenamine. Hridaya, are you there in the call?
Yes, ma'am.
Methenamine is stronger than ammonia. Is this clear?
Yes, ma'am.
Okay. Now, if I say If I increase the number of alkyl, okay, this is the one question. What if I increase the number of alkyl? So we can say among the 1 degree, 2 degree, and 3 degree. If suppose this is the ammonia, okay, this is ammonia, then this will have a less basicity than methanamine, which is 1 degree amine. Okay, then 2 degree amine, and then 3 degree amine. So basic character basically we can say depends on the more number of EDG group. More the number of EDG group, higher the number of EDG group, more will be basic. So basicity increases. Are you clear, Hridaya?
Yes, ma'am.
Their basicity. Learn next concept or you want break?
We have.
You want break?
Yes, ma'am.
Okay, no worry. Have some minutes break and then we'll join back. Hridaya, can we join?
Yes, ma'am.
Okay. Can you see the screen, Hridaya?
Yes.
It's visible, right?
Yes, ma'am.
Okay. Your voice is breaking. What happened? Some network issue or any problem?
No, ma'am. But ma'am,
You can
there
see
is
the
a
screen and
disturbance
my
in the
voice
back.
is proper, right? Audible to you?
Yes, ma'am.
Okay. So let's learn, Hridaya. We have seen that among the 1 degree, 2 degree, 3 degree, and ammonia, we compared that the compound will be going in this order, basicity, right? Let's learn now comparison. We have done one. The second comparison with the aromatic is left. So aniline versus ammonia we are going to learn. Okay. Let me tell you, phenyl ring is electron withdrawing group. Okay. So if I draw over here the aniline structure, NH2, I have written the 2 hydrogen single covalent bond. No issue, no? Hridaya, tell me. Okay,
Yes.
no worry. I'll write in a simple way. Let it be NH2 with a lone pair. Okay. What did I say? Phenyl ring is this ring, what it is attached. This is phenyl ring, right? This ring nature is electron withdrawing nature. An electron withdrawing group decreases electron density. Right? And it makes less available for hydrogen atom. All this concept is clear, right, Hridaya?
Yes, ma'am.
So what we can come to the conclusion? Less basic in nature. Did you understand? Hridaya, it is clear, right? All the explanation part?
Yes, ma'am.
Good. Now let's see how. I said this is electron withdrawing, means that electron will be taken away by the phenyl ring. So this electron goes towards to phenyl and it gets delocalized. Correct? Resonance structure. You can show. Carbon ion this turn, double bond. Since nitrogen gives the positive charge generates over here, and this bond as usual. Now this pair will shift here, this bond breaks resonance structure. Here we get the negative bond formed over here as usual, the next form, double bond as usual, hydrogen 2 and nitrogen positive. This shifts over here, this breaks and goes to corner carbon. So we get negative over here. Now this shifts over here, this go back. When this goes back, we get the nitrogen ka pair back. Right? And a plus charge disappears, get neutralized after getting electron pair back. But the double bond position changed, right? Let's count the resonance structure. How many did we get? 1, 2, 3, 4, and the 5. Hridaya, are you able to understand the resonance structure?
Yes, ma'am.
No doubt in the understanding resonance, Hridaya, right? It's very important. This all arrow is showing the electron displacement. This bond is due to the 2 electrons formation. This whole electron shifting, correct now? Electron displacement. dislocated from one place to other place. Here the generated negative ion, this shifted here between these two carbon, and this after this will cleave, and here the generates negative ion. This again will locate over here, and then this bond will be cleaved. This bond cleaves, gets the carbon ion done over here. We get again the movement, and this bond goes back to nitrogen. Did you understand the resonance structure? So what you are observing is here in benzene ring, since benzene ring is electron withdrawing group, it takes the electron away from the nitrogen and makes more less available for the proton accepting nature. So we don't find that basic characteristic present over here, right? So greater number of resonating structure makes the greater stability, right? So even here aniline 5 structures you have seen will be more stable than the compound, other compounds if you make, right? So but here what is the reason? We can say since it is being electron withdrawing nature, decreases the electron density over the nitrogen, correct, as compared to the ammonia, where ammonia mein pair will be as it is where there for available for proton, and it can form coordinate bond with the proton, right? We are seeing this characteristic in this example. So it is available for this we can say coordination bond, and the coordination bond generated over here, right? Whereas in aniline, electron pair is delocalizing, going away from it, right? It is not at one place where proton can come and attack. So basically, basic strength go less. So when you compare aniline is less basic characteristic than ammonia. Are you clear?
Yes, ma'am.
Ammonia is NH3, right? So aniline less basic than ammonia. You can write the reason. I wrote before, right? Because aniline is containing a phenyl ring, which is EWG group, electron withdrawing group, takes electron away from it, right? Decreases the density over the nitrogen, makes the nitrogen less available for proton. And as per the Bronsted and Lowry, if the compound is not accepting proton easily, then it won't be a good basic nature compound, right? Clear, right?
Yes,
Good,
ma'am.
yeah?
Yes, ma'am.
Okay. Now let's do chemical property. Is if your basic strength you have learned, let's do this now, the chemical properties. So here we go with the chemical properties. The most important chemical reactions will start with the carbylamine. This is important for your practical viva voice. Okay. This compound, it is applicable for 1 degree primary amines. Okay. And this I would say experiment or this reaction has a specific test that is called the odor test, that gives unpleasant smell like a foul smell. If you go near farm, chicken farm, like there you will get this smell. Okay, so that unpleasant smell which we cannot bear, that very irritating, such a smell is formed. So it is due to formation of isocyanide. That is the reason this reaction, or we can say chemical naming reaction, is kept in practical voice. It's a very specific reaction. Secondary and tertiary amine will not work out for this reaction. Let me name the reaction. The first we are learning is carbylamine. Have you heard this reaction? Hridaya, did you hear this name, carbylamine test?
Not sure.
You are not sure? It is there in your practical voice, viva voice. Aliphatic and aromatic, both. Okay, amines, they show this property, can be proven, can be tested. Okay, can be confirmed. Confirmatory test. What is this? Confirmatory test. How do we do this test? We take aromatic or aliphatic, whatever, primary amine, and this will be treated with the chloroform. This is chloroform, CHCl3. Okay, and this will be in alkali aqueous form, will produce isocyanide. This is 1 degree aliphatic amine. So aliphatic, aromatic, both are eligible. So we get over here NC. NC is what? Isocyanide. This produces a foul smell, very, very unpleasant smell. So basically, this is odor test. With its smell, we can check. Got it? So what you confirmed? Tell me. 1 degree aliphatic amine you have confirmed. Did you understand?
Yes, ma'am.
So how do you write this test? Aliphatic or aromatic 1 degree amine heated with chloroform, right? And we can say this will be alcoholic. So let me mention over here, ethanolic potassium hydroxide form isocyanide or carbylamine. This is also called as carbylamine. That is why it is called as a carbylamine test. Okay. So this has the foul smell. That smell is very unpleasant. Okay, and with this we can test, we can confirm. Byproducts are potassium chloride, KCl आएगा बाहर, H2O बाहर जाएगा. That's it. Let us balance the reaction, right? Okay. So 3Cl over here, 3 KCl needed, 3 KOH will put H2O, 3 needed, done. Right? Hridaya, are you able to understand?
Yes, ma'am.
I discussed your Viva voice question also here. So your examiner may ask you, okay, name the confirmatory test which is used for confirming 1 degree aliphatic as well as aromatic amines. So what is the name of the test? Carbylamine reaction. How will you confirm it? When this compound 1 degree or 1 degree aliphatic or aromatic is taken, treated with the chloroform. Chloroform is CHCl3 in the presence of ethanolic potassium hydroxide. It gives a false smell of the isocyanide or carbylamine that confirms the 1 degree aliphatic amine. Okay?
Yes,
Good. The next reaction with the nitrous. So what do you mean by nitrous? What is the formula of nitric acid? Hridaya, tell the formula of nitric acid. OUS suffix है यहाँ पे. I want you to tell nitric. What is the formula of nitric acid? HNO3, right?
yes.
I will just reduce one oxygen and put two. So when we keep the less oxygen, then it is called the nitrous. So what is nitrous? HNO2. It is clear?
Yes, ma'am.
Okay. So we say the primary aliphatic amines react with nitrous acid and they form again the diazonium salt, right, which is unstable. It is not like benzene diazonium. They may stable and form a compound and they can further go synthesis reaction. It's not like that. They are unstable. What happens when they are like just diluted? They can produce even alcohol immediately and it gives out the nitrogen gas. So learn the different reaction for the aliphatic and the aromatic. 1 degree aliphatic amine, when treated with the nitrous acid, it has different product. Okay. So RNH2 when treated with nitrous. So how the nitrous is produced, let me tell you. We will take the sodium nitrite salt and hydrogen chloride. Okay, so we get the product as nitrous acid. Got it? So what do you get over here? As a diazonium salt, which is unstable, very unstable. Okay? Just you dilute this compound, what you will get? So dilution ke liye, let me write over the arrow. What do you get? What did I say? Alcohol. You will get alcohol. Correct? And nitrogen gas will be free, N2. Clear? And we get as the HCl, because here we get the H plus OH minus. The OH goes with the R, nitrogen gets free, Cl gets H. So we get HCl. Are you clear?
Yes, ma'am.
Now aromatic amine mein, we have done this reaction many times. Aromatic amine, Sandmeyer reaction, remember? Naming reaction. So Sandmeyer reaction is where we can take the aromatic amine, treat with the nitrous, means aniline I meant to say. Aniline is only the aromatic compound in the syllabus we have. So let us take the aromatic amine aniline as and treat it with the nitrous acid. How the nitrous acid is produced, that's very simple. Either you write the nitrous or over the arrow you can mention the sodium nitrite, NaNO2. Okay, it is called sodium nitrite plus HCl. So both will produce the nitrous. This compound has to be treated at 0 degree centigrade, or in a Kelvin if you measure, it is 273 Kelvin. Okay. What do you get as the compound? Benzene diazonium chloride, N2 plus Cl minus. It is called BDC in a shortcut. But don't write this BDC in examination. You have to write complete name. Benzene we have to learn in detail about the BDC. Okay, let me tell you. Benzene means this ring is benzene. Di-azo go for nitrogen, two nitrogen atom, azo for nitrogen. And why IUM suffix is taken? Because positive charge over the nitrogen, and we have chloride Cl minus. So it's a salt. Got it? Got it? Is this clear?
Yes, ma'am.
This is quite a stable compound, as not like it is not like the primary aliphatic amine. Okay, so we get as the product over here sodium chloride and water molecule. Sodium, clear? 2 HCl needed to be taken. Is this clear? So what happens when aniline treated with nitrous acid? It produces the BDC, benzene diazonium chloride. Can you remember?
Yes, ma'am.
Okay. So if I'm talking about the secondary and tertiary amines, they do not react in a this order, how we are making it. Diazonium chloride and this way in the nitrous acid. They nitrous acid ke saath secondary and tertiary amines. Why? Because they have one hydrogen, one has no hydrogen. So their reaction will be quite different. Okay. So that is not the syllabus. So we need not to worry. So now the next reaction, which is very, very important. These are also very important. Hridaya, this is very important. Your carbylamine test is very, very important. This is your a very, very important topic. Even it is for practical portion, it's very, very important. Practical for Viva voice. Okay, let's do the reaction with aryl sulfonyl chloride. Okay. So Hridaya, what is sulfonyl benzene sulfonyl? Aryl ki jagah what we are going to take as BSC. It is not Bachelor of Science. BSC means I will take aryl ki jagah benzene. So benzene sulfonyl chloride. This is the reagent. Got it, Hridaya?
Yes, ma'am.
Okay. The reactant is amine, 1 degree amine. Okay. And the reagent is, this is the reagent. What is the reagent name? BSC. Okay, so all shortcuts I'm giving you to remember. So what happens when BSC? Now let's learn the how BSC will be. We will write the SO2Cl, sulfonyl chloride. ठीक है? Sulfur की valency is 6 sticks around it, 2 oxygen up and down Cl. So we say this is BSC. Right? Hridaya, it is clear? It's
Yes,
very
ma'am.
simple. This is BSC, benzene sulfonyl chloride. Treating now, I'm going to keep the hydrogen in front of it. Why is that so? Because we want this HCl to go out. Okay. So we can say HCl goes out. And what do you get? Everything gets substituted. Sulfur, double bond oxygen, nitrogen ke saath bond, nitrogen holds one hydrogen, and C2H5. Now let me share one interesting thing. This compound holds one hydrogen. Okay, Hridaya? So since this compound holds one hydrogen, it remains its acidic character with it. Whenever a compound holds hydrogen, that indicates the acidic nature. Due to this, it becomes acidic. When this becomes acidic, will be soluble in alkali then. So alkali ka matlab ki sodium hydroxide. Example. Got it? So hydrogen which is attached, right? Why this? So which compound is acidic? The first compound when it is treated with 1 degree amine. When sulfonyl BSC treated with 1 degree amine, what do you get? Acidic compound which is soluble in alkali. Got it? Is this clear?
Yes, ma'am.
Okay. Now here we can say another reason can be explained that sulfonyl group is electron withdrawing group. Sulfonyl. SO3H sulfonic acid it is called as. Okay. So sulfonic group is highly, we can say, electron withdrawing group, EWG group. And you know what the EWG group does? This decreases basic character. Opposite में it increases acidic strength. Can you understand in this way? Basicity decreases, but acidity increases by the EWG group, electron withdrawing group. Are you clear? That is also a reason we can say this compound is soluble in alkali. Are you clear? Let's see what happens when it is treated, BSC treated with 2 degree amine. So 2 degree ka 1 hydrogen I'll keep in front of Cl so that I can show the removal, and the 2 ki jagah I will jagah write I will ethyl. Okay, no worry na. Hridaya, you are able to understand. I'll remove HCl, and what we get as product, everything gets substituted. S double bond O, added N, C2H5. So nitrogen you can see clearly does not have hydrogen. So first of all, most important thing is this compound is not acidic compound. Correct? Are you clear?
Yes, ma'am.
So what reason you will write over here? Here you have hydrogen. Here you do not have hydrogen. Oh, sorry. Clear, Hridaya?
Yes, ma'am.
So since it does not contain hydrogen, right? So it is not acidic. Okay. When it is not acidic, then it is insoluble in alkali. Did you understand the concept? Very good. Now let me tell you the 3 degree amine. 3 degree amine does not react. Why it is not reacting? Because does not have hydrogen. HCl कैसे निकलेगा? Right? You can see in both the reactions, we are showing removal of HCl. Can you see here? This compound is also showing loss of hydrogen chloride. This also shows loss of hydrogen chloride. And this compound does not have hydrogen after losing it. So this is not acidic. That's why it's soluble in acid. Did you learn, Hridaya?
Yes, ma'am.
It is able, right? You are able to understand now? See the reactions?
Yes, ma'am.
Okay, Hridaya. Now I will teach the next properties in the flowchart form. Okay. Electrophilic substitution reaction of aniline. Electrophilic substitution reaction. ठीक है? This is for aniline. Aniline compounds property. So we have bromination, we have sulfonation, nitration, all that we have. So, okay, no worry. Step by step we'll go. Later we'll see chart all together. The first is bromination. Let's learn here because we have two ways of treatment. Bromination, as I always say, with bromine water will produce one compound. Remember, so aniline is the reactant treated with the bromine water, Br2. Okay? So this is bromine water set. Okay? This compound will produce single product. Second place, right, with respect to amine group, right? This is first, second, third, fourth, fifth, and sixth. We get second place Br, fourth place Br, and sixth place Br. So what do you call this as? 2, 4, 6 tribromo, right? And aniline. It is clear?
Yes.
And plus 3 moles of HBr goes out. The second here bromination possible, let's do in a controlled manner. What is this called? As the controlled manner. And when you do in a controlled way, right? Controlled bromination. So here we do in the presence of anhydride. Aniline first it will be saved. Group will be saved. So how are we going to save? By treating it with the acetic anhydride. So always the compound, whenever aniline is done in controlled manner, this step will be common for all sulfonation, nitration, bromination. First aniline will be treated with an anhydride. So anhydride said this product will be formed always C double bond amide group. Okay? Acetamide, which is called as phenyl ethanamide. Okay, we call it the IPAC. Okay, so let me tell, this is N substituted phenyl ring. So phenyl and 1 and 2. So we can call it as ethanamide. N phenyl ethanamide. Did you learn the name? How we have written? Then this will be now treated with the bromine. Okay, and acetic acid. So acetic acid will help to react at the para position. So controlled way may we get the major product. We don't get the two ortho and the para like that. Electrophilic substitution goes like that, right? So we are just letting the group to be confused, right? And by just, and then we are retaining it at last. One bromination happened. Now Br will go to the para position because all acid groups are active over here. So this does not interfere this position. So it will go directly to the para position. Did you understand? So major product we get over here. And then acid hydrolysis we do. And after this, we can retain our aniline product. NH2 group I meant to say. Acetic acid will be out. So NH2 group comes over here and para position Br will be present. So we get the 4-bromo aniline. Right? And CH3COOH will be out. It is clear now? This is controlled way bromination. Clear? Even the nitration, if you do in the controlled way, first it will be treated with the anhydride, same product will be produced. Para position nitro group goes, then acid hydrolysis, then gives para position nitro. Sulfonic acid, we do not have controlled way, we have directly reaction because that is already acidic in nature. Correct. So let's learn the second reaction, nitration. Nitration may we have both the option, treating it with the concentrated nitric and sulfuric acid, and then treating it with the controlled manner. So let's see over here, when aniline treated with concentrated H2SO4 and HNO3. So what product we get as over here? It comes as the para, okay, meta, and the ortho. So para position is the major product, but here not that high we are getting. So that's why we are want the production to be good and we apply controlled manner. So we get around somewhere 51%, which is not major product as per the industrial point of view I'm talking. So here we get the para position, meta position. Meta basically it is not the product for the electrophilic, but here we get, because nitro group is acylation reaction, that compound meta position, meta directing anilinium ion, you can see that is there, right? So it will produce this compound Br. So this is actually meta is more than ortho. So here we get the ortho very least product, very minor. NH2 and the ortho is together, right? So Br, sorry, NO2. So ortho is very, very less. Ortho, I would say how much? It is very, quantity is very, very. So how much is left? So 8 and 2% left. So just 2% over here we get. So this is not actually acceptable as per the industry point of view. If you see the production, it's like quite wastage of the reactant and product what we, sorry, reactants and the reagents what we are using, because we don't get good yield. Na? So let's do in a controlled nitration form, controlled method. Okay, so this is called the controlled nitration. So controlled nitration follows the same rule. Take the aniline, treat it with the anhydride, and let this position to be saved first. Okay, so we treat it with the CS3CO whole twice O anhydride, and we get amide. So top way we get N, triple bond, always you check around the nitrogen. So we get over here 1, 2, 3 stick, right? Double bond and CS3. Around the carbon 4 stick, around the nitrogen 3 stick, around the hydrogen 1 stick. Okay, like that. Now you do the nitration, treat it with the HNO3, okay, and H2SO4, and make the para position with nitro available. And once the para position by nitro is formed, do hydrolysis, so aniline can retain, can come back. Sorry, can be formed, reformed. So we want that our amine group to be present, right? We are just letting the group to get confused, isn't it? So NO2 comes at para position. Now, once we get the NO2 at para position, do the acid hydrolysis. Acid hydrolysis may we get the product as NH2 over here and nitro group over here. And same acetic acid goes out. Clear, Hridaya?
Yes, ma'am.
Okay. Third reaction. This is second reaction. Third reaction, sulfonation. Sulfonation के लिए do not require the control, because sulfonation gives the product as the sulfonic acid, which is already acidic, and there can be proton transfer, let me tell you. And this compound, even the hydrogen can be transferred and the compound can form the salt as well. Okay, sulfonilic acid it is called as. So it is quite different from other. So aniline, when it reacts, why it is reacting? Because aniline is, nitrogen is holding a pair of electron. It is attracting proton from the sulfuric acid. Sulfuric acid gives the H plus and HSO4 1 minus. Correct. So this H plus and HSO4 1 minus, like this you can understand. Okay, H plus goes to here, lone pair ke side mein. So we get NH3 plus. Did you understand? Hydrogen आ गया यहाँ पे, nitrogen takes that, and we get the HSO4 attached to it. Did you understand? Then you heat it. Okay, what you will get? Now aniline will be left and H2 over here, and sulfonic acid will come down. Now here, since this is lone pair, so hydrogen can go up. This is the possible nature. So they are resemble. Correct? Equilibrium will be established. Coming, going, this nature will be present. So NH3, 1 plus over here, and SO3, 1 minus over here. It is kind of zwitterion compound will be formed. Do you know what is zwitterion? When two opposite dipoles, correct? So that is called the zwitterion. Did you understand?
Yes, ma'am.
Okay. And this reaction, Friedel-Crafts acylation and alkylation, not possible. Why it is not possible? Yesterday we have discussed over here, because the same rule will be applicable over here. Aniline is base, na? So if you use this compound, this reaction, there you have anhydrous aluminium chloride as the catalyst, right? So the catalyst nature I taught you. What is the nature? It is a Lewis acid, and we have amine as a base. So acid base reaction can happen and it can produce salt. Where catalyst should not react. Catalyst should be enhancing the rate of the reaction. But here we are seeing catalyst is reacting. So that's the reason this reaction is not possible. Friedel-Crafts alkylation, acylation does not take place. Did you understand why? Because the catalyst used in this is anhydrous aluminium chloride, which will act as a Lewis acid, reacts with the amine group, which is basic in nature, and produces salt. So to avoid this reaction, we do not perform Friedel-Crafts acylation, alkylation. Okay, Hridaya?
Yes, ma'am.
So now we have to learn in detail about the benzene diazonium chloride. This is actually the salt we have to learn, and this is as example we are learning. So BD benzene diazonium salt. This is your topic. Under this topic, we are going to learn example in detail. We need to know about the BDC. What is the general formula of the benzene diazonium chloride? It is represented as R2N, right, plus over here X minus. So R will be taken here. R stands for aryl group. Okay. X stands for the Cl, Br, right? HSO4 1 minus, anything can be taken. So if I take Cl minus, so I will say that is I'm talking about BDC, benzene diazonium chloride, correct? So there it is clear. So the structure goes over here. बेंजीन हो गया, बेंजीन के ऊपर नाइट्रोजन 2 हो गया, डाई एजो का मतलब 2 नाइट्रोजन, and it is plus because IUM suffix is present. Sodium, potassium, all they are metals and they contain positive after losing the electron, so they are called as potassium IUM suffix. So IUM suffix mainly comes for positive ion, those who are forming. Cl minus, so it is BDC, benzene diazonium chloride. Don't write this BDC shortcut in your exam. ठीक है हृदय?
Yes, ma'am.
Okay. So let's learn in detail about the BDC. Can we go? Or you are feeling tired?
Ma'am, we can continue.
Continue. Good. So then let's do the preparation. After this preparation, we will do the properties in all flowchart. That is easy. So the preparation we do from the, if you remember, aniline Sandmeyer reaction, aniline say we have done nitrous acid reaction. Remember aniline, same reaction I'm doing it. Okay. So it is getting repeated for you. Yes. 0 degree centigrade pe, what do you get as the product? Benzene diazonium chloride. I told you they are going to learn in detail this. So same over here, plus H2O. Did you learn this? So aniline treated with the nitrous acid. This is actually nitrite, sodium nitrite and hydrochloric acid ka combination, right? This will produce nitrous acid. Okay. So what do you get as the product? BDC, benzene diazonium chloride. This is the preparation. Preparation is easy, right? Let's do the properties. So properties mean you have chemical properties. Chemical properties will be very simple for you. Just to pay attention over here. It depends on two ways. The first, I would say the reactions which will be involved where nitrogen goes out. Reactions involved displacement of nitrogen. And second, reactions involving retain means we will retain this nitrogen. We will not let nitrogen to move away. Okay. So reactions will be involving retention of diazo group. So we have coupling reaction under it. So let me tell you how I have written. The first I have written that if I take this as benzene I have written in horizontal manner. So N2 and the Cl. Okay. So if I just remove from here this whole part, are you understanding? Hmm? And
Yes,
substitute
ma'am.
some group, then that follows the first one. Okay. The second rule, if I just retain the nitrogen, I don't remove the nitrogen, let the nitrogen to be there and add some group. Second group will be, second type of reaction will be this. Okay. So in the first, you will see benzene diazonium will produce something else. And the second may coupling reaction means they will attach with the other group by the bond nitrogen, double bond nitrogen. Very interesting. Okay. So I am going to teach you in a flow chart. Ready? Take aniline.
Yes, ma'am.
What I'm doing. BDC I'm doing and I'm writing anyway. BDC, benzene diazonium chloride. So I'm writing shortcut abbreviation so that we can save time. But in examination, do not write like this. Now the first goes reaction with the copper halide. Okay. This is in the presence of HCl. Remember, whatever reagent you take, that only the product will be produced. Okay, that is the product mainly. So it depends on what reagent you have selected. Got it? And basically, it's a very simple N2Cl goes out and that group gets substituted. So we get as the product over here as the chlorobenzene. Okay? Nitrogen is out. Second, same reaction possible with the copper halide bromide ke saath, but HBr taken over here. Reagent, you can see HBr here. Now I change the reagent, so product will be changed. यहाँ पे Br आ जाएगा. So haloarine can be produced by this way. If I use, look at over here, copper cyanide in the presence of hydrogen cyanide or potassium cyanide, कुछ भी ले सकते हैं. KCN also can be taken. Both are monovalent. ठीक है? So what will it produce? Cyano, benzene. ठीक? And nitrogen. So where it is depending, see nitrogen completely we are removing and Cl obviously will be going out. So where it is depending? Are you understanding? Reagent. It depends on reagent. Simple.
Yes, ma'am.
Next reaction. If I treat this with the copper, only copper metal, okay? This is called the naming reaction, Gattermann reaction. We learned the Gattermann-Koch reaction, carbonyl group, benzene mil gaya humko. Here is Gattermann reaction. Koch is not present. Got it? So what will happen? We get the product as chlorobenzene because we have used HCl plus nitrogen will go out. Copper is used, so copper, whatever X, suppose here the Cl present, so Cl goes out. Otherwise, whatever halide is there, that will go out. Okay? Same reaction can be done with the different also. Instead of Cl, we can take HBr. This is also Gattermann reaction. Same nitrogen goes out, Cu. Now X is what? Cl. This Cl is going out. ये थोड़ा different है. Got it? Can you see?
Yes, ma'am.
differentiating by color. So you can see that, right?
Yes, ma'am.
Next reagent, I'm using Ki, potassium iodide. We have done this reaction. Remember, benzene diazonium chloride. Oh, no, not you. Sorry. This reaction can be asked the question, write the reaction, chemical reaction, where benzene diazonium chloride, right, replaced by iodide ion. So what is the product? Iodobenzene. So when you have to prepare iodine, what you need, iodoarine, iodobenzene, you need to treat with the reagent potassium iodide. Remember. So it gives out the nitrogen and potassium chloride will go out. Okay? So it depends on only reagent. थोड़ा ये different है. Here what do you get as the benzene के साथ N2 substituted product first we get, and then upon heating we can have the fluorobenzene. ठीक है? We can have boron trifluoride out and nitrogen out. This is hydrogen, we call it as a fluoroboric acid also you can call it, right? Fluoroboric acid. Clear? Even it can be reacting with the phosphoric acid, phosphorus acid, right? Hypophosphorus, all those reactions we have. So this is hypo. With hydrous form, it will produce benzene. Very, 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 very important. So what is the product over here? From this, we get benzene, right? Nitrogen and phosphorus we get as the acid, hydrochloric acid. Got it? And then again, if we use ethanol, alcohol, so also we can have benzene, same product, okay? Plus nitrogen out. Instead of acid, we will have aldehyde because it is alcohol. So takes the oxygen here, HCl as is the product we get. Got it? What happens when we do the hydrolysis? Hydroxyl group when it is attached. So it gives phenol. So this reaction we have done in phenol chapter. Right? What do you get as phenol? Just take benzene diazonium chloride and treat it like do the hydration, correct? Hydrolyzed. So if the phenol gets we can say hydrolysis of the benzene diazonium chloride produces phenol. So here what do you get as the byproduct? Nitrogen hamesha out, right? HCl. Clear?
Yes, ma'am.
Even the alternate way we have the fluoroboric acid, which I have said you, right? Fluoroboric acid will be producing one substituted product, that is N2 plus BF4 1 minus. So if you treat this compound with the sodium nitrite, NaNO2, so nitro group will be formed, nitrobenzene. So benzene diazonium chloride is the one platform where all train will be arriving, all trains. You can see all products, almost all types of compounds are forming. This is the one platform, isn't it? It's chlorobenzene, bromobenzene, cyanobenzene. Just which train we need to catch, it depends on the reagent. Sabka gadi number change hai. Correct? Phenol, then we can have nitrobenzene. All types of products will be prepared from the BDC, benzene diazonium chloride. Hriday, are you able to understand?
Yes, ma'am.
NaBF4. Okay, now the last coupling reaction and our chapter is over. So the last second type reaction, what is that? Reactions involving where retention will be taking place. Diazo. This is simplest reaction, I will say. Coupling reaction, very important for short note, 2 marks question. Coupling reaction. Okay, very, very, very important coupling reaction. So coupling reaction may we will take the benzene diazonium chloride. I'm taking in horizontal manner and N2 को I'm making the bond form. ठीक है? 2 nitrogen held with the triple covalent bond, positive and negative Cl का, that is balancing the stick around it. You may have a question like, ma'am, you said the 3 stick around the nitrogen, but I could see 4 are there. That is the reason positive ion. Positive means lack of electron. So that fulfilled by the electron. And here what we can see, 1, 2, 3, the same thing, like this is getting shared between these two. Okay. So that is almost balancing the valency of nitrogen. So always the coupling will be going with this bond leading to this product. This bond will be there, coupling bond. Remember, okay? Are you clear?
Yes, ma'am.
So let's see the product. When the BDC, benzene diazonium chloride, this is BDC, treated with phenol. Phenol का structure is, this is phenol. ठीक है? तो यहाँ पे hydrogen है, यहाँ भी hydrogen. I will highlight this hydrogen. So I can show the hydrogen chloride का removal. I am taking in horizontal. इसको सुला दिया OH को, phenol को. ठीक है? This is phenol. So now H I am highlighted over here so that I can show the HCl removal. So when HCl goes out from here, what you get as the product, I said the nitrogen, double bond nitrogen is the bridging element to connect these two different groups. This is called coupling. Something is joining. Correct? Did you understand?
Yes, ma'am.
It's looking nice. So with respect to nitrogen, this is para position, opposite. So we call it as a para hydroxy. ठीक है? Para hydroxy azo. This is azo group, na? So para hydroxy azo benzene. This is common name, not IUPAC. Let me write the color. It is orange color, dye. Clear? Coupling reaction, second, this is first with the phenol, second with the nitrobenzene or aniline we can make even, and let's do with the aniline, which is there in the syllabus, that only will do. Same, plus Cl minus plus aniline ka, the tail hydrogen I am highlighting over here, opposite side I am keeping NH2 group. Clear? So HCl I can show loss. Okay, I did not use this color. It is clear, no, Hridaya?
Yes, ma'am.
So here we get loss of HCl, hydrogen chloride, nitrogen double bond nitrogen, and groups are attached. Aniline groups attached over here, and we get benzene attached. Now, can you name it by yourself? Para amino azo benzene. Amino group, right? This is called the amino prefix as the prefix. So it is not the IUPAC common name only. Para amino azo benzene. Arabian letter I am writing. Para amino azo benzene. Clear? Hridaya? Over. We are done with our syllabus amine chapter over. You like this chapter?
And to my team from 1 hour observation,
Hridaya?
and
Yes, ma'am.
That's all.
we are
The
in
end.
a hurry to talk.
Okay?
Yes, ma'am.
I'll send you this notes.
Theoretical
Yes,
knowledge of anything.
Okay?
Like, do you
Any
have
doubt? If you have, you can ask me now.
Yes, ma'am.
Do you have any doubt, Hridaya?
No, ma'am, no doubt.
No doubts?
a
Okay, Hridaya. See you tomorrow then.
framework
Yes,
and
ma'am.
items that you need that
Bye-bye.
will you
Thank
be
you,
able
ma'am.
to show me
Bye.
that?